In a sector of a circle, to find the area A of a sector of a circle, we use the formula A equals half r squared theta, where r is the radius of the circle and theta is the angle in radians contained by the sector. Now, let's take this example. Find the area of the sector of a circle of radius 12 centimeters given that the sector subtends an angle of 0.5 radians at the center of the circle. So, the radius of this sector is 12 centimeters, so r equals 12 centimeters. And the angle subtended at the center of the circle by the sector is 0.5 radians, then theta equals 0.5 radians. Now, to find the area of this sector using the formula A equals half r squared theta, the area of the sector equals 102 times 12 squared times 0.5 equals 36 centimeters squared. Now, let's take a look at a few more examples. The sector of a circle AOB has an area of 12 centimeters squared and the angle AOB is 1.2 radians. Find the value of r. Given that the angle subtended at the center of the circle by the sector AOB is 1.2 radians, theta equals 1.2 radians. And the area of the sector AOB is 12 cm squared, so A equals 12 cm squared. Now, to find the value of r, we can use the formula A equals half r squared theta. So, 12 equals 102 times r squared times 1.2. 12 equals 0.6 times r squared equals 12 divided by 0.6, r squared equals 20. Now, taking the square root from both sides, r equals the square root of 20, r equals 4.47 centimeters. Here, we use the positive square root as length cannot be negative. Moving on to another example, the sector AOB of a circle has an area of 19.2 centimeters squared and a radius of 8 centimeters. And the angle AOB is theta radians. Find the value of theta. The area of the sector AOB is 19.2 centimeters squared, so A equals 19.2 centimeters squared and has a radius of 8 centimeters, so R equals 8 centimeters. Now, to find the angle theta, we can use the formula A equals half r squared theta. So, 19.2 equals 102 times 8 squared times theta. 19.2 equals 32 times theta. Theta equals 19.2 divided by 32. Theta equals 0.6 radians. Now, if we take this circle here, this is a sector of this circle. Now, let's say this sector is AOB with radius r and the angle AOB is theta. So, a sector of a circle is the portion of a circle enclosed by two radii and an arc. Now here, the sector AOB has two radii r and an arc AB. So, let's say the area of this sector is R1 and the outer part of this sector has an area R2. The sector covering the small area, that is R1, is known as the minor sector, and the sector covering the larger area, that is R2, is the major sector. Now, let's take this example. The sector AOB of a circle of radius 1.2 centimeters subtends an angle of pi over 5 radians at the center of the circle. Calculate the area of the minor sector and the area of the major sector. So, first I'll label the area of the minor sector AOB as R1 and the area of the major sector as R2. Now, to calculate the area of the minor sector AOB, we can use the formula A equals half r squared theta. So, here r equals 1.2 centimeters and theta equals pi over 5 radians. So, using the formula A equals half r squared theta, the area of the minor sector AOB is R1 equals 102 times 1.2 squared times pi over 5. So, R1 equals 0.72 times pi over 5 equals 0.144 pi centimeters squared. Here, I left the answer in pi. Now, to calculate the area of the major sector R2, we can use two methods. First, we can calculate the total area of the circle and subtract the area of the minor sector from it to find the area of the major sector. So, the area of the major sector equals the area of the circle minus the area of the minor sector. Now, as we all know, we can calculate the area of a circle using the formula area of a circle equals pi r squared. So, the radius of the circle is 1.2 centimeters, so r equals 1.2 centimeters and hence the area of the circle equals pi times 1.2 squared equals 1.44 pi centimeters squared. Now, since we know the area of the circle as 1.44 pi centimeters squared and the area of the minor sector R1 as 0.144 pi centimeters squared, we can calculate the area of the major sector R2. So, R2 equals 1.44 pi centimeters squared minus 0.144 pi centimeters squared equals 1.296 pi centimeters squared. So, the area of the major sector R2 is 1.296 pi centimeters squared. Now, another way of finding the area of the major sector is by using the formula A equals half r squared theta straight away. So, we know the radius is 1.2 centimeters and hence r equals 1.2 centimeters. Now, when finding the area of the major sector using the formula A equals half r squared theta, here theta is the angle subtended by the major sector at the center of the circle. So, this is theta. Since we know a circle has an angle of 2 pi radians around the center, then theta equals 2 pi minus pi over 5 equals 1.8 pi radians. Now, since we know theta using the formula A equals half r squared theta, the area of the major sector R2 equals 1 over 2 times 1.2 square times 1.8 pi equals 1.296 pi centimeters squared.